All right, now problem 3 of tutorial 2. There are 5 parts here, but all of them are fairly straightforward, so I think I'll just record all of them in one chunk. Okay, so that's just a few partial derivatives to practice. All right, so here we've got to find the partial derivative with respect to x evaluated at the point 3.4. Now, I kind of find it usually easier to probably substitute the given values first and then to differentiate, right? But since we are differentiating with respect to x, right? So it means that we can take 4 and substitute instead of y, right? And then we differentiate with respect to x. So doing that, we will get d over dx of x plus 4 minus square root of x squared plus 4 squared is 16. So, and this is just something familiar from calculus 1. Right, so dx of dx is 1 minus differentiation of the square root is 2 divided by square root of x squared plus 16. And then we need to differentiate to x squared. 2 and this will yield 2x. Right, so 2 over 2 cancels out. And then we've got to substitute the actual value, so x is now 3. So we get 1 minus 3 divided by square root of 3 squared is 9 plus 16, which is 1 minus 3 fifths, right? 9 plus 16 is 25, square root is 5, so it's 2 fifths, or if you want, it's 0.4. Okay, second. Now we've got to, so here is the expression, and we need to differentiate it and evaluate at the point 0, 0. And again, since we are differentiating with respect to x, it means that we can substitute the value of y first. And it kind of becomes easier. So now if y is 0, it kind of simplifies stuff because cosine 0 is just 1. Right, so what we get is just x times cosine 0 is 1 minus y, y is 0, so 0 times cosine x is still 0, x divided by 1 plus sine x, and we need to differentiate it with respect to x. And then after differentiation, we plug in x equals 0. So this is the fraction, so we've got to use the ratio rule, right? So first we differentiate the numerator, and its derivative is 1 times the denominator, 1 plus sine x, minus, we keep the numerator, and now we differentiate the denominator, and the derivative of 1 plus sine x is just cosine x, and then we divide by 1 plus sine x squared. Right, and now we let x equals 0, and it should simplify stuff, right? So because sine 0 is 0, so we get just 1 times 1 minus 0, essentially divided by 1 plus 0 squared, so it's just 1. Okay. All right, so now here is the expression, and we've got to differentiate z with respect to x, not at any particular point, but in general. So we just use the differentiation rules, right? So dz dx is what? Logarithm, the derivative of logarithm is just 1 over whatever is inside the logarithm, is 1 divided by square root of x plus y plus square root of y times the derivative of this, and here we've got ourselves a square root, so it's just 1 over 2 square root of x plus y, and then the derivative of x plus y with respect to x is just 1 because y does not depend on x, and we also have the square root of y. Its derivative is 0 because it's not x really, and that's basically the answer. Okay, 3 3d. So here it's sort of theoretical, so we don't have any specific um, function as g of t, so it's just like in general. So f of x and y is the integral from x to y of g of t dt, and we need to find the partial derivatives of this function with respect to x and with respect to y. And g here is supposed to be continuous function, continuous function. And how do we do this? We've got to use the fundamental theorem of calculus, right? So basically, you can pause the video if you don't remember. Do a bit of googling. Fundamental theorem of calculus. You've got to do this and probably read Wikipedia or something. Okay, but then what does the fundamental theorem of calculus tell us? Yeah, it tells us that the derivative of an integral with respect to its um, upper limit of integration is just the integrand, right? So basically, so df dy is just um, g of y. That is just the fundamental theorem of calculus. I mean, in kind of, if you compare it to I guess Wikipedia, um, so let me see, geometric meaning. So yeah, okay, right. So this part. So if f of x is the integral from a to x of f of t dt, then its derivative with respect to x is f of x, right? So if you switch a to x, x to y, f to g, then you will exactly get this, whatever this is, right? So now, how do we find df dx though? Well, to find the df dx though, so you need to realize that if you switch the limits of integration, then you get the same thing only with a minus sign, right? So um, f of x y, if you rewrite it as the integral from y to x, then you just need to write a minus sign in front of it, and it's going to be correct. So why do we want to do this? Because in the fundamental theorem of calculus, we are differentiating with respect to the upper limit of integration. Right? So which is now easy. So df dx is just basically minus the integral from, sorry, we've got to differentiate this integral with respect to x, but then it's just the integrand, so it's going to be minus g of x. Okay,